Okay, so we were just talking about the exciting world of covalent bonding. We were talking about how much fun we're having. Yeah. Anyway, we were talking about what is covalent bonding? It is the sharing of pairs of electrons between two atoms, and it allows these two atoms to achieve stability. And you might hear, some about molecule or atoms that are highly reactive. This is what we're talking about. They're trying to gain this stability, this desire that they have. So we had mentioned water. We had just talked about water, and we were saying that we have a pair of electrons that's being shared by this hydrogen, and a pair of electrons that's being shared with the oxygen from that second hydrogen. And we had said that these electrons, they're free to go between the two atoms that are sharing them. This hydrogen and this oxygen, and this hydrogen and the oxygen as well. And I said there are two kinds of covalent bonding. So I'm going to back away and I'm going to show you oxygen gas. Another woohoo moment, I'm sure. So oxygen gas, what I've drawn here, we said, so oxygen has an atomic number of 8, so that means it has those two inner electrons. I didn't draw them. And then 6 on the outside. And so you see we got an oxygen here and an oxygen here, and each atom has 6 electrons, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and we had said in order to gain stability, it needs 8. So what you have is a double covalent bond. And so what we're saying is that this atom shares these 2 electrons with this atom, and it also shares another pair of electrons with this atom. And again, these electrons can go over here, or they can go over here. Okay? They're free to roam between the atoms where that they're connected to. Now, I have a question for you. Which atom do they like the best? Do they like this atom better, or do they like that atom better? I'll let you think about that. Well, you'd probably say, well, I can't even imagine why there would be any difference in one atom, one oxygen versus another oxygen. And yes, you are correct. They are equally shared because there's no difference between, effectively, there's no difference between this atom of oxygen and this atom of oxygen. So those 2 electrons that are free to go from side to side are equally shared. And we call that nonpolar. And that means that they're flying back and forth and they spend about the same amount of time over here as they do over here. Now let's go back to our water. Let's think about it a minute. We've got 8 protons up here, and we got a single proton here, and then we've got a single proton here, and we'd said, here you're sharing a pair of electrons and with this oxygen, and here you're sharing another pair of electrons. And if I pose that same question to you, where would they prefer to be? Okay, electrons are negative. They love those positives. There's 8 positives up here and only 1 down below. So the electrons spend more time up by the oxygen and less time down by the 2 hydrogens. So this creates a polar situation. This is a polar covalent molecule. And what that means, and again, we think about positives and negatives, so that means that, and a battery, or a magnet, right? It has a positive side and a negative side. Well, think about this. You got the extra negatives up here, so this is the negative side, And then they are missing those negatives that they wish they had down here. So this is the partial positive side. So in a polar molecule, polar covalent molecule, you have one end that is a little bit negative, partial negative, and one end that is a little bit positive because it's minus the negatives. So it's a partial positive. And what did we say about positives and negatives? They attract. So what would that tell you if you had a whole bunch of water molecules all together? They would probably stick together. And because the negative part would stick to a positive part of another molecule, and then it would have its negative part sticking to a positive part of another, and so on. So polar molecules, like water, have really unusual characteristics. But this sticking together, and one of them is something called, one of the weird characteristics of water is something called cohesion. If you put a drop of water on your car, it'll bead up. If you had, so polar molecules stick together, and so they bead up. Now, gasoline is nonpolar. I didn't draw it up here, but it's like this. There is no reason for the electrons to be at one end or another. It doesn't have those partial charges. So if you were to put a drop of gasoline somewhere, it won't form a drop. It's just going to flatten out, whereas water beads up. And so this sticking together of the individual water molecules is our third kind of bonding. And it's hydrogen bonding. It's polar covalent molecules sticking together. Okay? So the next lecture is going to pick up a discussion of this molecule, this polar covalent molecule that hydrogen bonds with others of its kind, other water molecules sticking together. That's what hydrogen bonding is. And it's because it has a negative side and it has a positive side, and these molecules can tumble and roll and take, different shapes. So you have a whole bunch of them mush-mashed together, all sticking together. And that is hydrogen bonding. So, just in quick review, we have ionic bonding. It's where one atom gives an electron away to another, and it becomes negative, and the one that received the electron becomes positive. We then have covalent bonding, which is sharing of pairs of electrons. Sometimes they're equally shared, nonpolar covalent. Other times they are unequally shared, polar covalent. And then the third kind of bonding is the sticking together of polar covalent molecules. This sticking together is called hydrogen bonding. All right, we're done with the lecture number 2. We'll talk about this the next time we meet. Yeah? Okay, have a good day.